It's on. Hey, there we go. Okay, everybody, let's go ahead and get kind of rolling here. We have a few people probably join us in a little bit. Okay, I've got some news to share. Okay, this is about RTC mix and what we're trying to find out about. What's happening with it in this god awful operating system from hell called Big Sur. Okay, um, right now RTC mix tilde does not run on under max MSP on Big Sur. However, it does run under PD. So what I'm going to start doing is putting up some PD patches along with the other class patches, so that if you need to run, if you have a Big Sur machine and you need to try and run some of these RTC mixings, PD is very similar to Max MSP. It's just not as fancy. For example, it doesn't have a native slider object, so you're just going to be kind of looking at little window things that have a number, and you can scroll the number up and down in place of a slider. I believe we didn't check it out, but I believe RTC Mix Shell also runs on Big Sur. But yeah, that'll only get you so far because we're looking at interactivity. All right. I did find out that this is a crash that is not specific to RTC Mix. I did a little bit of research, and it turns out that there's a number of other software applications that are having a very similar kind of crash. And people are going, "What's going on? What's going on?" And indicative of the fact that this may not be something that I can solve, some of the solutions that were offered were pretty bizarre. One is that if you change the name of your Macintosh, supposedly it might fix it. Now, if that doesn't make any sense to you, it doesn't make a lot of sense to me either. But this does seem to be, it has something to do with the dynamic loading of C++ libraries. And yeah, some of my friends from Cycling 74 looked at our crash reports and pointed out that this is going on. So we got some things to try. Hopefully we'll get something working pretty soon and it'll be good. The other thing is that um, if you have, I think even Catalina through Big Sur, you're going to run into some problems when you try to run URTC mix inside Unity, because the gatekeeper, that other horrible thing that Apple has promulgated upon the world, will prevent it from running. It'll tell you the software is damaged or it's not from a licensed developer or all that nonsense. There is a good fix that's pretty easy for this. It's the same fix as what you do for Max MSP. You basically just drag the URTC mix folder from your Unity project into this terminal with a command set up, and it'll just fix it and it'll allow it to run. I'll show you that when I start up my screen share so that you can see what's going on there. Okay. All right. Other than that, we're going to kind of move on forward here. And let me set up a few things here I forgot to do. Okay. Let me start by asking if there's any questions or concerns. I mean, we're flying pretty quickly through some stuff. It'll start to level out. I mean, the learning curve initially is a little bit steep, but it'll start getting a lot more fun too, because we're going to start using some of the more advanced tools coming up starting next week. But has anybody been having difficulties or concerns or anything like that? Nope. Looks like we're all okay. Great. Again, just drop me some email. We can meet, anytime over Zoom, and we can start talking about some of these things. Yeah, I had a good talk with Max Gupta earlier, and we're trying to solve John's problem with multi-channel output. These things, they'll all come to pass. Life is good. Okay. Thanks, Max. I appreciate the thumbs up. Okay, so tonight we'll see how far we can get. I want to go over we've been building really goofy little Unity scenes. We're still going to work with a really goofy little Unity scene, but I want to talk about how you do some audio interactivity and how you are able to get things that are happening in the scene reflected in the audio that's being synthesized. So let's go ahead, and I'm going to share my screen. And the first thing I'm going to do, though, is show you how to fix that problem if you've got a warning from Apple saying that it's not going to run the software. So here we go. Share screen. Okay, share computer sound. Okay, let me get this here. Okay, go back and say share. Okay. All right. So here we are. Oh, it looks like hopefully when we first started the session tonight, the internet was really bad. It looks like it's working okay. So I hope everybody is able to hear this and all. And again, if you've got questions, shout them out because I can only see about 4 of you right now. I can see John and Nina and Justin. That's about it. So anyhow, okay, gang. Here's what you do. Okay, let's go here to this main page running RTCMX tilde on OS X and Windows. Okay, this is where you got the objects from. This is not where you got the URTCMix. That's a different page. Okay, that's basically here. Okay, take you here. These are all linked in. Okay. Yeah, this is the URTCMix page, and this is where you download this Unity package. That's the thing that you drag into the Unity project to get RTCMix to work. Now, here's the deal, okay? Look at this. Okay, this is just the generic, running RTCMix tilde. And here, note, if you're installing and getting on Catalina or later, you get the truly annoying gatekeeper message about it can't do this, okay? Okay, click the instructions here. I'll put a link to this on the web page, okay? This is what you do. Start up a terminal window, type in that with the space, okay? And then what you're going to do is it says here to drag the RTCMix 2.01 folder in. No, the one you want to drag in, okay? Shoot. Hold on. My Zoom thing was getting in the way. Okay, let's go take a look at here, soft spring. Okay, and let's look at what we did last week. Here's our Unity project. Okay, so this is sort of what you see when you look at the Unity project on the disk, okay? You look at assets, and here, this folder, URTCMix, that's the one that you drag into that terminal with that command, okay? Once you drag that folder in, you hit return, and it'll work. Okay, basically that removes the gatekeeper attributes from everything within that folder. So that's all you need to do. I'll put some modified instructions up on the web for this too. So if you do run into this problem, you'll be able to solve it. Okay, so at least that one we got going. Yay, good for us. Okay, all right, but let's now do some stuff. Okay, we're gonna go to week 3, and I want to basically. I want to modify our ambient sound a little bit because first of all, I wasn't really happy with the way it came out. I wanted it a little bit lower key, literally in certain ways. But I'm also going to use it to show a particular way that we can chain some sound producing processes together to get particular effects, okay? So what we're going to do is we're going to start out here, and I may go ahead and bring this up. No, I'm going to build it by hand first of all. Okay, let's go to Max 7. Okay, all right, and let me start out here. Okay, we're going to build something here. Okay, let's make this a little bit bigger so that you can all see it. RTCMix tilde. Okay, 2. Okay, and that's all I want to do for now. Okay, so we're going to trigger it with a bang. I'm going to send it to an easy DAC. Okay. And here we go. Okay, and we're going to kind of repeat some of the stuff that we did last time real quick, but I'm going to start doing some things differently. And I want to show you some things about this too, okay? Let's go and save this just in case we crash. Okay, soft spring, week 3. We'll call this, dang it, you guys can't see this, but this stupid Zoom menu is getting in the way of everything I do. Okay, there we go. Okay, all right, we'll call this new ambient 1.max patch, okay? So let's go out and we're going to use that wave table again. So I'm going to go to the RTCMix documentation, go to instruments, go down here to synthesis, wavetable. Let's just copy this whole thing, okay? Go into our RTC mix, paste it in as a comment so we can see what we're doing. Okay, and let's start filling in the parameters. Well, we want to start immediately. Duration, we're going to make that a parameter. So we're going to say dur equals, we'll say 7.0. Why will we say that? Because I already experimented a whole lot and I found that that was a pretty decent one. Okay, that's the fun part, is that you can experiment with a lot of stuff and work on this to try and get different sounds and things like that. Okay, so the amplitude, let's say the amp, we're also going to use that as a parameter too. We're going to say amp equals 10,000. Okay, and we'll call that amp. Notice that the case is you do have to be aware of lower and uppercase here. Because it does differentiate between the two, okay? And now the pitch, okay, we were calling it a value that we called freak, and we're going to say frequency equals, and we're going to choose a random number. Before we had it between like 700 and 1500 or something like this. I'm going to make it between 200 and 400, okay? So we'll put in frequency there, okay? Pan, let's see. We'll make that random at first, but we're going to be altering that a little bit. We're going to make it irand between 0 and 1. And now we're going to use this thing here. It's an optional parameter that says wavetable, okay? But before we do that, let's go ahead and put in our amplitude envelope, okay? Because we don't want the clicks at the beginning. So we're going to use that make table command. We're going to make a line, okay? It's going to be 1,000 points. Okay, and it's going to be at time 0, it'll be 0. We'll use a scale of maybe 130, it'll be 1. At 70, it'll be 1. And at 100, it'll be 0. Okay, now I want to show you guys kind of what's happening here, because I don't think I did a great job of explaining this earlier. Let's we'll create an image. Okay, that sounds good. Okay, basically what we're doing is we are specifying with these numbers a particular shape, okay? And these times, when I say at time 0 be 0, at time 30 be 1, again, they're always relative to the duration. So this is basically, think of this as being 30% at this point, okay? So this is 0.3 times 7 would be that time. Well, what are we doing here? Well, we're saying at time 0 be 0, and then at time 30 be 1. It will draw you a line virtually inside one of these buffers. Then at time 70, still be 1. And then at time 100, be 0. Okay? I hope that's clear to everybody. And then what the computer does is it actually samples this, turns it into a whole bunch of numbers that it just stores, and it uses this as a template, that we can consult when we're actually synthesizing the note, and we're then multiplying it out here times our amplitude. Let's say amp times amp in. Okay? So that's how we get, a fade up and a fade down, for example. Okay? But this other thing, wavetable, if you look at the documentation for the wavetable instrument, it says this is a waveform that you can use. Well, it turns out that we can use that same sort of make table stuff to produce waveforms. And in fact, right now, the default waveform that it makes is a sine wave. Now, some of you that don't know about synthesis don't know too much about what different waveforms sound like. I'm going to put a link on the web page to some basic synthesis stuff so that you can hear. Sine wave is basically the purest tone that you can get. It's very like a whistle kind of thing, okay? But I wanted something a little bit beefier. So I'm going to say wave equals make table. And then how do I create a waveform with make table? Let's go back to our documentation, okay? We're going to go to now, this is not an instrument, it's a score file command, because that's what we use in the score to do something in the score. Oh shoot, everybody froze again. Did you guys catch any of that I said?
You lagged out for a second.
Okay. Okay, I just said that we're going to look at now a score file command rather than an instrument, because this is used by the score. Oh, shoot. Oh dear. Uh, uh,
We can see you moving fine, Brad. Can you hear us? I'll take that as a no.
okay. Can you guys hear me now?
Yes.
Wait. Yes. Hold on. Can you guys hear me?
Yes.
Yes.
Okay. Okay, but you couldn't see the screen. I only see about half of you actually showing up on my screen. It's still really bad.
Your screen though when you were checking your internet connection, I guess.
What was that? What was the question?
We could see your screen before when you were checking up to your internet.
I suspect you can't hear me now.
Still loud and clear.
We can hear and see you.
You can hear and see me now. Okay, it's kind of coming and going.
Yes.
Okay. Yeah, see, I can get a sense of it. I have on my second screen, I can see actually what I'm broadcasting. Okay. Okay.
Well, as long as you don't need the interaction from
Okay. Okay. Let's do that. All right. Okay, I'm going to try my screen share again. Okay. And shoot, let me see if I can get the chat window up while the screen share is going on, because then you can chat with me to tell me if you're not getting stuff. Okay. Let me see what I can do here. Okay. Share computer sound. Share. Okay. Let's see. Chat. Okay. All right. I have the chat window up. I'm going to keep that up. Let me know in the chat window. You can hear me okay now? Okay. All righty. Okie doke. Well, here we go. Oh, it's always exciting in this bold new internet world. Now I see absolutely nobody. So I'm kind of flying blind here, but let's just go ahead and fly. What the heck? All right. So what we're going to do though is we're going to look at that wave table and figure out at that make table. We're going to figure out how to make a waveform with it. Okay, so if we go down here, see this is where this envelope control is, function tables, inner p field variables. We're going to talk about those later today. And there's this make table. We've been using the one that says line, fill a table using straight line segments. And that's what I gave you a demonstration of, okay? But look down here, here's one that says wave, fill a table with one cycle of a waveform. Whoa, that's what we want to do. So here we go, okay? I'm clicking on wave. Yep, the enter.
Okay, so Brad is gone
Goodbye,
for a
Brad.
moment.
Oh,
Hello,
I see.
Brad.
I see that. I don't see Brad's
Oh yeah,
screen.
yeah, it's the other laptop, I think.
Brad, you
You're
are
muted,
muted.
Oh, you're right, it muted everybody. Okay. Right. Okay, I think it reset itself, and actually I think it's a little better than it was, maybe. Okay, here we go. Okay, are you guys hearing me okay?
We hear and see you fine. Right.
Okay, sorry about that.
Yes.
Somebody said this is like having a Ouija board seance. Like, can you hear me? Give us a sign. Okay, let me share the screen again. All right, here we go. Share. All right, now what we were doing is looking at this as making a waveform. And this is how you do it. It's very easy. You just say wave, then the size, which is always 1,000, then the wave string. These are all the wave strings that you can use, okay? Like you can create a sine wave, or you can create a sawtooth wave, or you can create a square wave, or you can create a square wave with only a certain number of harmonics. That's what we're gonna do, okay? Okay. Yeah, I see a note from John.
Brad. You don't have to stop and answer my question
Okay.
to me while you teach.
I think you said something to me, but it sounded like a piece of computer music. It was kind of fun. The library, okay, yeah. Okay, there you go. Yeah, people are gonna answer it. I'm gonna barrel ahead here. All right. So here's what we got. Okay, we're gonna make a thing called wave, and it's gonna be a wave. Okay, we're gonna make it 1,000 points. We're gonna say square. Can't type there. And we'll give it like 4 harmonics. Okay. So down here where it says wavetable, we just use that variable wave. Now at this point, this won't be a sine wave. This will be a square wave with 4 harmonics. So it'll sound a little bit different, okay? And then in order to get it to kind of recirculate, I'll say max bang, okay? And I'm going to say jur times 0.2. Again, I fooled around with that, but basically that allows me to change the duration and still have an overlap of the notes, so I don't have to change it in 2 different places. And this allows me to determine how much overlap I'm going to have on the notes, okay? So let's hear what this sounds like, because this one wasn't as bad as that horrible sine wavy sound, but then we're going to make some additional modifications, okay? But even before that, I want to do one other thing with this, okay? So here we go, and let's bring our bangs around so that it re-trigger itself. We'll get like multiple notes. Boom, boom, boom. There we go. Let me make sure that we are going to the Zoom audio output. No, we're not. Zoom audio device. Okay. And now you should hear nice square wavy things. So sound a little bit nicer, I thought, you know, and it has a bit more kind of crunch to it. All right. Now I want to do one more thing to show you just how this works. By the way, let's go back to our little graphical thing. And when we specified that make table with a wave, let me get rid of the arrowheads here. Okay. Plane. When it said to draw a square wave with a certain number of harmonics, basically what it did was it drew a table that looked kind of like this. Okay, and that became the template for the waveform. Just like we made a control signal that was a template for the amplitude envelope, this was then used by the wavetable instrument. It said, oh, there's how I make a square wave with a certain number of harmonics. And it could then just access those numbers over and over again. This is an efficiency thing because it didn't have to calculate a square wave function with a certain number of harmonics in order to make this happen. So that's how that works. But here's the fun thing you can do. Okay, let me get rid of this. You know, we can go back and just for fun, let's use this amplitude envelope. Remember, starts at 0, goes up to 1, stays at 1, goes back to 0. What happens if we also multiply that by our frequency? Think about it, okay? We're specifying a frequency. It's going to be between 200 and 400. But as the node is synthesized, it's going to be multiplying it by this. Here's what it sounds like, okay? Let me turn, yeah, here we go. See what's happening? It's taking that control function, multiplying by the frequency over the duration of the note. So it starts out with a frequency of 0. Then for 30% of the note, it goes up to 1, so it will hit whatever frequency it chose, okay? So we can use these control functions to basically control anything inside this instrument, okay? Now, some of you probably heard there was that weird squeak sound at the very beginning, all right? That's for a specific reason. We're assuming that we're giving frequency in cycles per second. There are other ways of specifying the pitch or the frequency, okay? In fact, one of the most common ones is called octave point pitch class. If I take this and I say 8.00, that will play a middle C. Middle C is considered octave 8, and then the 0.00 is how many semitones above it. That's a C sharp above middle C. That's a D, okay? That's an F, that's a G, that's an octave above middle C, which is the same thing as saying 9.00, okay? These are all useful when you start wanting to do things more tonally or, you know, based on pitches. The really fun things about this, though, is that you can also do things like 8.02 that and create really weird microtonal stuff if you want, okay? Now, that weird glitch that you heard, and the way that we tell whether we're specifying in hertz or in octave point pitch class is that if this number is less than 15, it will interpret it as an octave point pitch class number, because you can't hear a frequency that's lower than 15. I mean, you can't really hear 15. It's like a thump, 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 thump. Okay, so because this was actually going down to 0 for the first very small part of this rise up, it was going from 0 to 15, and it was interpreting it as actual octave point pitch class numbers. So basically, it was playing the entire piano keyboard during the first 10 seconds and the last 10 seconds of each note. Okay, so just to kind of point that out for fun. All right, so there we are. Okay. Oh, I don't want to do that. Okay, I'll do this instead. Okay, so we're saving that. Now, I want to do a bit more. I like the way this sounds, but it's not the ambient sound of my dreams, okay? I want something that's going to be kind of a little bit, well, let's listen to it again, okay? Okay, by the way, just to show you what can happen, let's just say straight square here and listen to what that sounds like that. Okay, this is a straight square wave, which is really awful. Okay, it has a bunch of higher harmonics. Let's maybe make it a square wave with only 3 harmonics. That might be even better still. Okay, like I said, this is the fun, is you can start fooling around with this and carving away at the sound. Okay, all right. I want it to be kind of more ethereal, kind of like really kind of hang out there. One way to do that would be to increase the duration and increase the overlap. But that's not really that satisfying. I tried it out and it didn't work very well. What I'm going to do instead is I'm going to add an echo to this, okay? And the first way I'm going to do that is I'm going to get rid of these. I'm going to add a new RTC mix tilde here. 2 channels. And what I'm going to do is take the output of this one, which is making the wave table. I'm going to run it into the inputs of this one. Then I'm going to take the outputs of that one and run it there. Okay? All right, now, since I have a second RTC mix, I'm going to have to trigger it with a bang. So I'll set that up. What am I going to put in here? Well, what I'm going to put in here is another instrument. Okay? And that other instrument is going to be one of our delays. We've got all these different delays. I'm going to use one of my favorite ones. It's called pan echo. Okay, so rather than reading the documentation, like I said, I know how it works. I'm going to just copy this as going to be my template, put it in here, bang. Okay, there we have all that stuff. Okay, and let's fill in the stuff here. Okay, outskip. Well, we want it to start right when the note starts, right? In skip, well, this is if we were reading from a sound file, we could specify how many seconds to go in to start reading. But we want to start reading right away because the sound is coming. So we'll say 0 for that. Now here's the fun part, duration. Okay, each of these notes we said was 7 seconds long, but they're going to continue to go forever. So essentially we want to let this echo thing keep on going forever. How do we do that? Well, we just put in some really huge number. It'll go for like a couple of hours. We could go longer if we, if we wanted, okay? So we'll do that. Now amp, this is different. Remember I said that when we're synthesizing sounds, we use that weird scale that goes up to 32,768. And I've been saying like 10,000. Well, in a signal processing instrument, the amplitude is a multiplier of the signal coming in. So it already has an amplitude. So if we want it to be at full amplitude coming out, we just say 1, okay? Now, I happen to know that it's going to get a little bit loud if I do that. So I'm going to make this be 0.9, turn it down a little bit, all right? Now, here comes the fun parts. This instrument produces a delay that goes to the left channel, then to the right channel, then to the left channel, then to the right channel. These are times in seconds for how long it will take to go to each of these channels and back again. So let's say our channel 0 delay is going to be, say, 0.9 seconds. We'll say 0.95. And our channel 1 delay, we'll say, will be 3.2 seconds. Okay? So it's kind of a long delay. It should kind of build up a nice cloud of weird square wave-ish stuff. Feedback. Okay, once you generate a delay, how much then circulates back through and gets redelayed? Let's say this will, if you say 1 here, the sound will never die away and it'll just be obnoxious because it'll get really loud. Let's say 0.8. So this will keep the sound kind of in the delay lines for a while. Now this ring down duration and the input channel, we're just going to assume is going to be 1, 0. That's basically if you have a note that has a discrete endpoint, that's how long does it take for the echoes to die away. Since it's going forever, we don't need to deal with it. All right, so this is cool. However, how do we get the sound? How do we tell RTC Mix that sound is coming in from here? Well, that's really easy. You just say RT input audio. And in fact, this RT input, when we start talking about sampling and using sounds that are sampled on the disk, that's where you're going to specify where the sound file is located. But right now, we're just going to say, bring it in, okay? So let's save this, okay? And I'm going to save this now as a different name. Okay, we'll call this new ambient 2. All right. Now I start it up. And if I start this out, we won't hear any sound, because I also have to start the pan echo first, okay? So I'm going to start that up, and now we'll hear. Okay, so that's starting to sound kind of fun, okay? If we wanted to get really carried away, we can do this, okay? We can say pitch dev equals 9,000, 0, 0.9, 100, 1, freak times pitch dev. Actually, let's make it be 0.8, okay? What do you think will happen? We're going to get these nice kind of ascending tones. Okay, yeah, so that's working. That's kind of fun, okay? Okay. All right, so when I put these headphones on, I can hear what you're hearing, but it means that my voice is delayed, so that it's very difficult for me to talk. This is actually a treatment that they use for people who have stuttering problems. They delay the voice going into your, because you hear yourself talking later, and yikes. That was pretty weird. Okay, we'll go back to this. All right, so now we're kind of having some fun. And we can do this in Unity, okay? We can actually have two separate RTC mix processes going, and one would be processing the output of another one. Okay, but I'm going to show you one that's a little bit cleaner in terms of getting things into Unity. And it essentially, it makes this connection between the two objects inside the script itself, okay? And that's done using a special instrument called called bus config, okay? And here's how it works, okay? At the very top of this, I say bus config. I give it the name of the instrument, wavetable. Bus is like the generic audio term for how you get sound from one thing to another, okay? Wavetable has two outputs, and normally they would go to out 0, 1, okay? That's the default use of wavetable. However, we're going to send it to augs 0, 1, out. Why? Because then we're going to have a bus config for the pan echo instrument, and it's going to take augs 0, 1 in, and then it's going to go to out 0, 1. Okay? What we've done is we've replaced this. Now we're also going to have to get the pan echo here, but we no longer need this RT input audio because the bus config has made that connection. So let's grab this, okay? Put it in here. Okay? And you think, oh, great. We've got this all set, okay? We have, dang, what happened to it? Did I forget to save something? Oh, no, there it is. No, there's not. Ah, okay. I have to retype all that. Sorry, guys. Actually, let me see if we can reload it, okay? Nope, can't. Sorry about that. Stupid, stupid me. Okay. Bus config wavetable augs 01 out. Okay, bus config pan echo augs 01 in out 01. Okay, all right, and we've got our pan echo down here. Now you're thinking, oh, this is great. Okay, however, this will not work. Here's the problem. Remember I said that we have to run the pan echo just once. We start it up and it runs for 999 times. And this bus config, we only have to do it once, right? This script, the way this is set up, is going to get repeatedly triggered over and over again because that's the thing that sets up our notes, okay? So that means that every time there's a new note, it'll reset those bus configs, which will give you a click, and it'll start another version of pan echo. So after like 3 or 4 notes, we're going to have like 4 echoes. You know, after 20 notes, we're going to have 20. It's just going to be a mess. How do we set it up so that we can trigger these guys just once and then do the wavetable stuff we need to do like repeatedly? Well, it turns out that RTC Mix has a magical feature, okay? Oh, it has many magical features, okay? Come on. We're gonna get rid of this guy, okay? Go back to our kind of plain thing here, okay? And I'm going to now save this as a new patcher, okay? Save as, and we'll call this ambient 3.max patch, okay? Each one of these RTC Mix things has actually a number of different scripts that you can have on it, okay? And we're going to trigger those different scripts with a message. Go script 0 is the first one we're going to create. And this guy is going to say go script 1. Now, you don't realize it, but you've already been using this. Basically, you've been using script 0 for everything, okay? And we can actually see those individual scripts by saying open script. If I can type properly, 0. And of course, open script 1. Well, let's take all this stuff. Let's open our script 0. Let's take everything from here just to make sure we have it. We're going to copy it. And now we're going to put it inside script 1, which is empty. Okay? Now we're going to go back and we're going to whittle out what we don't need. Okay? Open script. Let's do script 1 first. Okay? Obviously, we don't need the bus configs. And to tell you the truth, we only need to specify all this stuff once, right? The pitch deviation and all that, you know, these are static variables that we set. Amp is not going to change. It's always going to be 1,000, okay? So let's get rid of that. Our frequency, this is script 1. This is what we're using to generate each note. Our frequency does change. So we're going to keep that in here. We're going to get rid of this. We're going to get rid of this. So the actual running script is just those 3 lines. We choose a frequency, generate a note, generate a max bang, do the whole thing again. So that's our kind of our run script. In the meantime, our setup script, we do need all this stuff. We need the bus configuration. We need to set the amp band and the amp. We need to set the wave. We need to set the pitch deviation, all this. Frequency, we don't need. Wavetable, we don't need. Maxture, we don't need. And the pan echo, we do need. Okay? So now we have 2 different scripts, one that sets everything up and one that goes over and over and over again. So we can actually just trigger this and you'll hear exactly what you heard before. That sets it all up, that makes it go. Okay, coolness. All right. Now, it turns out that in Unity, we don't even need to mess with this different scripts or anything like this, because we have total control over when we send different things to the RTC mix engine in Unity. Okay, so this is just, we would be using these to copy out and maybe use the squirrelizer to put them in the appropriate place. But you know, we don't necessarily have to say, oh, script 1, script 0, or anything like that. That's just a convenience in Max MSP and also in PD, you know, so that we can separate out the initialization from the runtime. Those are the official words for those things. Okay, all right. Tell you what, let me show you a Unity patch that's already kind of pre-made, because then we're going to kind of modify that to add some interactivity to it. Okay, so let me close off Max MSP here. Okay, and we'll hide this. Okay, and I have here, yeah, I'll open up my Unity hub here. Okay, I'm going to do week 3 Unity. Yes, this is the one. Okay, here it comes. Okay. Can you guys hear me? Yeah. Okay, I'm going to change some things here. Yeah, I'm going to change some things. Okay. 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 Can you guys hear me?
Yes.
Okay. All right. Okay, I think this is set up. This is that weird thing I have to do in order to get Unity to play properly. So I'm monitoring you now from this other thing. I'm not hearing you for some reason. Okay, well, I'm hearing. Oh, actually, I think this is working. Okay. All right, now, here's what I did. Okay. I basically, this is what we had done last time. Okay, and let me show you down in the URTC mix folder. I have set up the thing that will move. There's the ambient sound. Oh, this is the, I did something a little bit different. Okay. Rather than just attaching the sound script in this case, I created an empty object right there, okay? And that empty object has this script on it, this ambient sound script, okay? Let me put this up here. Actually, let me put it down here. Actually, let me put it like this, okay? All right, okay. Sorry, I'm trying to collect my thoughts here for a second, okay? Let's take a look at this script, okay? This script is attached to this ambient sound object that I created, okay? And it has an audio source on it, and it has that script ambient sound attached to it. Well, let's take a look at the script, okay? Basically, this is what we did last time, okay? Here it comes. You guys are still hearing me okay?
Yes.
Okay. Okay, good. All right, here we go. All right, close this. Okay. So we're going to look at ambient sound. There we go. Okay. And this is what we did. Okay, first of all, we're using this system. I'm going to change this so you don't have to put that in anymore, but that's to allow us to use this string variable declaration here. And we entered in our object number. We found our RTCMix object there called RTCMix main. That's that guy that has all that stuff on it, okay? We did that when it woke up, and then we initialized it, and then look what we see here. Basically, I use this squirrelizer. Oh, let me, I don't need to have this anymore. I was doing some debugging. We'll be talking about that in a future class. Okay, but this, notice there's the bus configs we typed in. There's the amp end, the amp. I don't have that deviation thing in here. I hadn't yet. There's our pan echo, and then we send a bang, because what that bang does is that triggers this. And that's where we have our wavetable and our max bang that goes over and over and over again. So that's going to be the source of our sound when we do this. And again, we got the sphere and other things like that. We'll be talking about that in a second. But let's just go ahead and try playing some of this, and hopefully it'll sound okay. All right, let's go. Oh, man. Didn't sound okay, did it? Hold on. I need to change something here. Okay. Let's try this. Can you guys still hear me okay? Okay. Let's try.
Yep.
I'm about to use some bad words about Zoom. Let me see. Let me think, how did this happen? Okay, let me go here. Okay, our output. Ah, here's our problem, I believe. Let's hope. Let's try it now. Ah. Okay, and you can hear me? Okay, all right. So at least this is pretty insane, you know, but I'm glad we're able to hear it at least. Okay, so basically that's where we were at the end of last class, with one exception. We did add the capability of moving the sphere, okay, and we created the script called sphere move. And if we look at the sphere, we can see that we have that script sphere move on it with an up down speed, and I set it to 0.1. Okay, let's just take a quick look at the script. Okay, and then we're going to go into start making some fun things happen with this sphere. Okay, so here we go. Double click on the sphere move, and essentially we don't have any audio with this right now. We just have this Y val, this up down speed. We set it initially to 2, so the sphere is up above a little bit, up above the plane. Okay, and then we are getting these keys, and when we get a right curly bracket, we add the up down speed. When we have a left curly bracket, we subtract it, and x0 0, and then the new Y val based on those modifications. And that's happening in update. So that's happening about 60 times a second. You know, that's the nominal frame rate in Unity, okay? So now we can go back to this, and we can actually, and also I had put the observer move script onto our camera so we can kind of fly around a little bit. So let's fly around and move our sphere up and down. So here I go. I'm going to move the sphere up and down. There we go. Okay. Life is good. Okay. Sorry about the sound quality. At least it's not going like it was before. I think there's some ways I can make it even a little bit better, but I'm not going to mess with it right now. Okay. All right. So tell you what, let's just keep this Unity thing kind of up because we're going to start modifying it. What I want to do is add the capability of the sphere is going to be generating sound. Okay. And as it generates sound, as it goes up and down, we're going to change the pitch depending on how much it goes up and how much it goes down, right? So let's go ahead and create our little sort of sound here, okay? And rather than painfully watch me type in all that stuff, I've already gone ahead and created some max patches, and we're going to use not wavetable but a different RTC mix instrument called Strum2, okay? Get this going here. Okay. Here's what it looks like, okay? What I got from this is what's called a physical model. It makes a very interesting effect that sounds like a plucked string, okay? Outskip duration, you give it an amplitude, a pitch, and then the squish. This is part of the model. It's between 0 and 10, and the closer it is to 0, the harder is the pick. So a value of 0 would be like picking it with a metal pick. A value of 10 would be like picking it with a really fat thumb, kind of going fa, 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 kind of like that, okay? Then the decay time we just set to our duration, and then the pan, we're just setting it at 0.5. We're going to put it in the middle for now, okay? How does it sound? It sounds like this. Oops. Yeah, there we go. Yeah, sounds like this. Yeah. So it has a nice plucky string quality to it, okay? How do we get that to change its pitch while it's being synthesized, okay? Well, somehow we're going to have to change that value, okay? Now, we can't type in here, we can't say freak equals something or freak equals something random because we want the value to be determined by an external thing, in this case, the height of the sphere. Well, we have a max patch that'll do that, okay? This is it, okay? What have I done, okay? Well, in here, you'll see that there's a strum, and it has this value freak, and then it sends a max bang of 0.1. So every 10th of a second, it's going to generate a new strum, and it's going to use that value. But look, that value doesn't exist. Oh my goodness. And no Go scripts or anything. But look over here. There's a slider that generates numbers. And in front of each number, it says freak equals. So that's going to get sent in as if it were part of this script and allow us to change the pitch. All right, that's how we're going to do it. I don't know, are you guys seeing a delay between when I move the slider and when you actually hear the sound?
A little, yes.
Yeah, I think that's just Zoom does some weird disconnect of the graphics with the sound sometimes. So, yeah. Oh, Raina was asking, does that work the same in PD? It does, Raina, but essentially you don't have a slider, okay? All you have is this value thing here, okay? So it still works the same, but you have to do something like this, okay? Okay, like that, okay? I think you can get sliders for PD, but they're like a third-party add-on or something, and I just don't want to deal with it. What I'll do is I'll create a PD patch and put it also on the website that has this stuff in it, okay, for using people who are using PD, okay? All righty, so that's what we want to do. Now, all I need to do is basically just take those lines and use the squirrelizer or something like that, and we're going to embed them inside our Unity project, okay? Now, Where are we going to embed them? Well, let's bring the Unity thing back up, okay? Here we go. Boogaloo. Where's my Unity? Down here. Okay. So we're going to take the sphere. Now the sphere is the thing that we're going to move up and down. So the sphere is the thing that we're going to attach the sound production to. So the sphere is going to be moving. It will be generating its sound, okay? So the first thing we need to do is to add to, actually, what we'll do is, let me see here first. Second, what we want to do here. We could add a new script to the sphere object, okay? But that would be a little bit, not difficult. It would be a little bit redundant because we already have a script, this sphere move script, and that's where we're already making the moves. So we're going to get from these keys, up, down, speed, and all this nonsense, we're going to get our information for doing the sound right there. So we're just going to modify the sphere move script to include sound, okay? And to do that, we're just going to grab the stuff we want from ambient sound, okay? First of all, we're going to grab this, okay? Actually, we're going to also grab this awake function. And actually, we're going to grab everything down through our start function, okay? Through that initialization, okay? So let's grab all this stuff, okay? I'm going to copy it out, go to our sphere move, okay? And we're going to put it right there. Okay, so we still have these guys. We still have this up down speed, but now we need to change the object number because this is going to be the second RTC mix sound producing object in our Unity scene. 0 is the ambient sound that we already had, okay, where we grabbed the stuff from. So we're going to make that be 1, okay? Everything here is cool, okay? This is not cool. We're going to get rid of that, okay? YY val, but now we're mix. We're going to need another public variable, okay? We're going to call, actually, we don't need it to be public. We're just going to say float freak, okay? Because that's a variable that's going to keep track of the frequency that we're playing. All right, now, sometimes you can see how this is also labeled private. I don't really understand the necessity of declaring a variable private or not even declaring it at all. I tend to be lazy and sometimes I just do this, but you could say private float bool freak. Why am I telling you this? Oh, because you might run into it and wonder what the heck is going on. Basically this and then this with a private in front of it is essentially kind of the same thing, even though I'm sure there's compiler differences and things like that, okay? All right, so we've got this, okay? And we're going to have to, yeah. Let's just do that, okay? So we've got all this. Now we have to do our stuff here. Anything here? We need to send the frequency value. We need to set the frequency value initially. So we'll say freak equals, we'll start out with 300.0 F or 300 Hertz, okay? And then we have to say cmix.send score, oops, okay? Freak equals, and then we're gonna do this magic. Okay, what's that doing? Well, that's saying it's going to send this score fragment to RTCMix, but it's also going to add onto that score this value that we've set here. This is critical because this is how we're able to get values from inside our script here, being sent into the RTC mix engine, okay? Now, we need to trigger it off then, okay? And we can do that by just saying RTC mix send score dot send score. We're going to send max bang. Now let's just send it like 1/10 of a second after we start, okay? 0.1, okay? Optional. Okay? Because what we're going to do then is we need the rest of our audio producing stuff from ambient sound. Okay, we need this on we need this on application quit. Now, if we get a bang, which we will from that, we're going to do something. What are we going to do? Well, we're going to do a couple of things. Okay, first of all, we're not going to do that because that's our ambient sound producing stuff. Okay, first thing we're going to do is we're going to say RTC mix dot send score freak equals plus freak, because we're going to send whatever the value of that frequency variable is at that point. Optional. Okay, then we're going to say RTC mix dot send score, and we're going to say right. Where is it? Where is it? Where is it? Shoot. Ah, there it is. Okay. Strum 2. Okay, and start of 0, duration of 3.5, amplitude of 10,000. Okay, frequency is now freak because we set that right there. Okay, okay, and then hardness of the plectrum of 1, decay of 3.5, 0.5. We'll just put it right in the middle. Okay, sending that to Obgno. And then we say RTC mix dot send score max bang to Obgno. Oops. Obgno. Why isn't it saying Obgno? There we go. Okay. So this will then pick up this value of frequency and send it around, generating a new bang, send it back around. All right, so this value of frequency, where do we modify it? We do that up here. We're already doing this to modify the up and down position of the ball. All we have to do is add the capability of modifying the frequency. So what we do here is if we're going up, which is Y-val plus thing, we're going to say frequency equals freak plus, and let's add 10 hertz to it, okay? Why 10 hertz? Again, because I did this ahead of time, and that seems to be a pretty good amount, okay? You can add or subtract however much you want, all right? And then if we're going down, we'll say freak equals freak minus 10.0 hertz, okay? So now whenever we hit those keys to make the ball go up and down, we're also going to be hitting the, we're also going to be altering the frequency to go up in pitch or down in pitch. That's exactly what we wanted to have happen. Okay, so now we have our interactivity. And I'm going to go out here, okay, and let's look at our sphere. And I'm going to play this, and it's not going to work, okay? Here's what happens, okay? Let's go. Okay. Now, I'll move it up and down. Notice that there was no sound coming from our sphere. That's because, and I did this purposefully because I do this all the time, and sure as shooting, you guys are going to do it too. You need to add a component to this. When we turn this script, this sphere move script into a sound generating thing, you need to add something to tell Unity that sound, you add component source. Once that happens, now we should be able to hear the strum on the sphere as we play this, okay? Let's go for it. Oh, you're still not hearing it, are you? I'm not hearing it either. Let me play this and see if they're getting any sound out of it. Don't worry, because I have a pre-made version of this that I can show you that does work. Yeah, something's not happening here. Let's see if I see anything obvious. If not, I'm going to load up the pre-made version. Okay. Okay. Let's see now. Nope, that all looks good. Ah, I see what we're missing. Okay, in my haste to do things, okay, I forgot to copy this over to let it know that in fact RTC mix is started. Okay, now I want to take a minute. You know, I'm doing a bunch of stuff here, copying, pasting, everything like this. The idea is that these can be templates for you to start working from. And as you get used to working with this stuff, you'll be able to, you know, get a sense of what you need and what you don't need. Okay. In fact, I'll be making a short little assignment later today. But let's go ahead and hear what this sounds like. Okay. All right. Here we go. Let's get our Unity back up and running. Where is it? There it is. Now, hopefully we will in fact hear a happy little strummy sound. No, dang. Okay, I'm going to give up on this because obviously, like I said, I'm just making some stupid errors here. In fact, I see what that error is too. Computers are really dumb. Now let's try it. We'll try it one more time, okay? And otherwise, I'll load up the other stuff. Okay, here we go. Yay. Okay. All right. Well, you can kind of get a sense of it. Sounds a lot better in person. Okay. So you guys will be able to download this project and run it if you want. It should sound okay. All right. So that's one way of getting interactivity to happen. Okay. I'm going to finish the class by showing you another way, because that's going to be critical to doing the localization stuff, okay? But this time, I'm not going to try and type all the stuff in, because that's just the road to madness, and all sorts of bad things happen as a result, okay? But I do want to show you what the sound is, okay, and how it's going to be different, okay? This time, we're going to take the sphere, and we're going to move it, but we're going to move it not only up and down, but we're also going to move it left and right. So we're going to have two different parameters, okay? And excuse me, what I have here is there's this instrument called frequency modulation synthesis, or FMINST, okay? And this is very familiar to people who've ever used like a Yamaha DX7 in the olden days or things like that. It's a way of synthesizing sound where you have two different parameters that control the sound you're hearing. You have what's called the carrier, which is a certain frequency, and a modulator, which is a certain frequency. Now, we're not going to go into the details of the synthesis. Again, I'll put some stuff on the website that'll point you to, you know, how you can do FM synthesis and understand it. But basically, these are all the parameters for the FMINST, okay? The ones we're interested in are modifying that carrier and modulator, okay? Basically, with these set up, this is what it sounds like. Okay, pretty thrilling, I know, okay? But here's the fun part. Notice I have two sliders set up here, okay? One here and one here. And again, in a PD, it would just be those boxes like that. But I've done something else with the RTC mix tilde object, okay? Basically, I've added a second optional parameter that tells me how many additional of these inlets do we want here. Because I have one slider going to one and another slider going to another. That's because in here, I'm saying that we're going to get the carrier frequency from making a connection to that first inlet with a default of 300 hertz, and modulator from making a connection at second inlet with 400 hertz. So the carrier and the modulator equals, or frequency equals, okay? In fact, we couldn't say that because we're only triggering this script once. Because the FM instrument is running continuously, we're giving it a really long sort of duration again. These will actually reach into the instrument as it's playing its sound and change those values relative to each other. These are called, by the way, P fields, okay, for various historical things, okay? And it's a way of dynamically modifying the sounds. If you've noticed, some of these parameters in the documentation are capitalized. Those are all parameters that can be modified in real time, okay? And they all have different effects on this FM synthesis. But again, we're just modifying this carrier frequency and modulator frequency. And here's what it sounds like, okay? Okay, so each one of those changes an aspect of the synthesis, okay? So let's attach that now to our sphere, okay? I'm gonna quit Max because we're not gonna do anything more in Max tonight, okay? Let's go out to Unity. Okay, let's close this project that we did, okay? Let's save it, yeah. Okay, let's close this guy in Visual Studio, and let's bring up my Unity Hub. And here's the FMinst project that I've already made. Like I said, I don't want to like spend another painful half hour mistyping parameters and, you know, making it terrible. Okay. All right, here we go. Come on, Unity. Okay, here it is. So now on Sphere, again, we have that sphere move script, but we have an up-down speed and a right-left speed, okay? And of course, I've added the audio source because this is now a script that's gonna make audio. Let's take a look at the script and I'll show you what I had to do to get the FM instrument to work, okay? Here we come. There we go. All right. So there's our sphere move script, okay? Here's our familiar stuff to set up RTC mix. Again, we're using a second object because we still have the ambient stuff going in the background. We got the two variables there that we're going to use. And then we have these public variables that allows us to enter in the interface at 0.1 for the up and down and right and left. We find the RTC mix main object, that guy out there that has all the good stuff on it, okay? Then we initialize it. We set our carrier frequency, our modulator frequency, and then this is directly from the Max MSP script using Squirrelizer. There's where we make our connection to the first inlet. There's where we make our connection to the second inlet. That's where we set up the FM instrument to start making sound for a real long time, and we send that score to RTC mix. Started. Now we have an X val and a Y val. Okay, the X axis is basically the one that you're looking at, okay? How can I tell that? Well, look here, okay, there's this camera, okay? Notice that as I move it, this little guy up here moves, okay? the x-axis is that way positively. So we're looking at the sphere, that way is positive, okay? The y-axis goes up and down, goes up like that, down like that. And then the z-axis is kind of hidden, okay? There it is. The z-axis goes that way positively, okay? So we want to be able to see the sphere go up and down and left and right. So we're going to use the y-axis and the x-axis, all right? So we have our y val and our x val, and every time we get a key, okay, we have two new keys. We have the right closed bracket, the left open bracket. That's still going to control our y val. And we're going to add 10 hertz to the carrier value or subtract it when it goes up and down. So the carrier is going to be the up and down axis, but then we added two other keys right next to them on the keyboard, P and O. And when you get a P, it's going to move the sphere to the right because it's modifying the x val right there. And we're going to then change the modulator frequency. The O will do the opposite. Now, here's the fun part. In order to get those values to go into that P field thing, into the inlets and everything like this is all we need to do. To the first inlet, we send the carrier variable. To the second inlet, we send the modulator variable. And that's done with this function called set P field RT CMix, okay? That's all you do. Notice we have no check max bang because it's running continuously. It's just taking those values every time we change them, and it's going to just alter it automatically. So let's hear it. Here we go. Okay. Voila. We have our 2-parameter continuous control moving sphere, which is just more fun than words, I guarantee it. Okie doke. All right. I'm going to stop my share now and switch things back to kind of normal. Okay. Here we go.
Can you hear us?
I can hear you guys. Hold on a second. Okay, you should be able to Okay, you should be able to hear me. Yeah. Okay, you should be able to hear
Okay,
me
you
now?
should be able to hear me now.
Okay.
Okay.
Right. And
Now it's double.
and okay. Okay. Now it should be fine. Is it? Yay. Oh, this is a little nerve-wracking. I got to tell you guys, okay? Okay, doke. Hopefully that was relatively coherent and clear. You know, it's, again, we're kind of dealing with some actual constraints in terms of Zoom and such like that. And again, there's this weird compression that happens to the sound, but I think you could get a sense, I hope, of what it was supposed to sound like. And like I said, I'll set the projects up. It's probably going to take me most of the day tomorrow to get this stuff set up on the web, but yeah. Here's what I'd like to try and do, though. Okay, I'd like for each of you, if you can, to just try and make either a max patch or a Unity project that just makes a sound. Okay, I just kind of want to see where we are with everything, or a PD patch or something like that. So maybe for next time, just do something like that. You know, you can make it as fancy or as not as trivial as you want. You know, simply take one of my projects that I put out on the web, go in and just modify the frequency. You know, see where that gets you. You know, just to get a sense of, you know, how you can kind of make these things go together. We're, believe it or not, you're kind of over the hump in terms of some of the actual looking at code and programming, because essentially got most of the pieces in place that we need to do. There's one thing, two things left. Being able to measure proximity to objects and being able to trigger objects, or have particular objects trigger things when we get close to them or when we touch them or something like that, and it turns out that's not that difficult to do. So next time we're going to step back a little bit and maybe have a little fun playing with some of the more fun aspects of Unity in terms of like how you build a scene and stuff like that. So yeah, should be kind of fun. And then we'll just kind of keep on going. Yeah, so far we're kind of on schedule, but if it starts getting too rough, or please let me know if this is just completely befuddling you and I need to step back and kind of re-explain a few things. I'm happy to do that. And Nina's also very adept at this. I noticed from the chat that Nina's been helping quite a few people during the class. Thank you, Nina. Okay. So anyhow, yeah, I guess we got through today. Any questions or concerns so far? I mean, like I said, I hope this is relatively clear, because it is a lot of fun. I got to tell you, once you start really using it, it's just really, really enjoyable. Okay. All right. Well, we're winding up a little bit early tonight, but I think that's fine. I was thinking about covering the localization instrument, but that would just be too much because that one's a little bit weird. And yeah, I'd rather get through some other things first. And yeah, kind of take it from there. Okay, in the meantime, stay tuned. We're going to continue to work on trying to solve the problems with Big Sur. And, other than that, it should be all working okay. And like I said, I'll put up the PD patches. Just be aware the PD patches, the PD is a little bit more brittle than Max MSP. So, you'll get the hang of it, I think. All right. Okay, everybody. That's it. Until next time, like I said, send me emails, try this stuff out, and I'll be happy to answer questions. Nina can, and yeah, we'll see. Alrighty.
Thanks, Brad.
Okay.
Thank
See y'all
you.
later.